All right, good afternoon, everybody. I'm Gary Sharp with Safeware. We're just getting kicked off here in just a quick moment. We've got one more presenter that's trying to log in, Chief Murray from FDNY. Looks like he might have dropped off, but is logging back in. Hopefully we'll get him back on for his portion, the last portion of the webinar. But I'll start and let our guest, Jim, introduce himself first. Jim's going to do the heavy lifting here on the webinar, so I'll pause for a second. And Jim, why don't you go ahead and introduce yourself?
Hi, everyone. I'm Jim Foran, co-founder and CEO of PVStop, and we're here to make solar energy safe. So Gary will be starting the presentation, then I'll be getting to the main body, and then after that we'll be handing over to Dan Murray, followed by some questions at the end.
Great. Yeah, so as we're getting started, I think, almost everybody's got the memo now about the changing energy landscape. There's been a lot of focus on lithium-ion batteries and certainly a lot of loss of life from small mobility devices inside houses and apartments and things like that. But really the problem is much bigger than just scooter fires or the EV fires that we're focusing on. That whole changing energy landscape is almost becoming HazMat 3.0, right? HazMat grew up as responding for industrial chemicals. Then we had a post 9/11 Homeland Security phase. And really the future that responders need to be prepared for is all these different forms of energy. It's not just electricity and gasoline anymore. We've added to the concern CNG, hydrogen, batteries, wind, and solar. So regardless of whether they're at the fire department operations level or a HazMat technician level, agencies really need to start thinking about building a capability to respond to all these different forms of alternative energy. And when we say capability, we're really talking about three things. You need the equipment, the training, and the procedure to be ready for each of these different types of energy. Today, we're going to be talking about how to build your capabilities. What equipment, training, and procedures do you need to respond to some of these problems with solar panels? And that's where Safeware, we've worked pretty close with PVStop about, and we think this is a good equipment fit. We'll be talking later about training for agencies on solar cell emergencies. But with that, I'll kick this over to Jim. I'm going to be driving the PowerPoint. Jim's in Australia, and we find it runs a little better if I run it here locally. So Jim, thanks for getting up early. I'll let you take over, and just let me know when you want to advance each slide.
Sure. Okay, fantastic. Well, without further ado, everyone, we'll get into it. So Gary, if you could just flick to the first slide. So solar panels cannot be switched off. As long as they're exposed to light, they continue to produce potentially lethal amounts of DC electricity. In professional terms, this is known as the DC danger zone. And up until now, there's been no practical solution to this growing and global problem. So how big is the problem? Let's take a look. Just flick it, Gary.
Solar panels.
And a Fox 40 investigation into solar panel fire hazards.
Solar panels, they're good for the environment, but it appears they're bad for firefighters. There is a hidden hazard that firefighters call a growing concern.
Firefighters have a very tough time putting out the blaze. Why? Solar panels. This big study saying solar panels cannot be easily de-energized. They are inherently a fire trap.
So next slide, Gary. So whether it's utility or industrial scale solar, like at this solar farm incident, or next slide, or large commercial arrays on rooftops. A few examples here from the UK, the US, the Netherlands, and Australia. It's happening all over the world. Next slide, Gary. Or residential size installations. With the exponential growth of solar, we're starting to see a commensurate exponential growth of incidents. It's not that the technology is not safe, there's just simply so much more of it out there. And it's not just incidents where the solar is the ignition point of a fire. It's any fire at a structure or a building featuring solar panels. Next. So to give you a little bit of a market overview, currently there's over 5 million PV installations in the US. This is forecast to double by 2030 and triple by 2034. Based on Australian data, and Australia is a much more mature market solar-wise than the US. Here in Australia, now 1 in 3 properties across the country has solar. And what we've seen here is there's been a 500% increase in incidents involving solar over the last 3 years. And what does that mean for first responders? Risk your lives or let properties burn. Next slide. So this is just a bit of a graph of the global growth. And as you can see, although there's this sense that we've seen this huge growth in solar, we're still very much at the start, according to this graph. There's just going to be exponentially more solar installed over the coming years. Next slide. So the objectives today is to understand the nature of solar PV systems and how they work, what goes wrong with them, investigate the dangers or risks associated with the DC danger zone, talk a little bit about products, data and statistics and recommendations, and how does this impact your standard operating procedures. Next slide. So let's start right back at the basics, the differences between AC and DC electricity. So volts times amps equals watts. Watts is the measure of power output. You look at a general power outlet in a home, it's putting out 120 volts at 10 amps, which equals 1,200 watts or 1.2 kilowatts. Remove either volts or amps and you have no power. Why that's important, we'll come back to just a little bit later. Next slide. So understanding the problem. AC versus DC electricity. AC alternating current, it flows backwards or forwards at what's called a frequency. In the US, that frequency is 60 cycles per second or 60 hertz. AC can be easily remotely detected. We've got AC hot sticks as fairly standard equipment that allow you to detect whether an AC electrical source is live without directly engaging with the electricity. It's very easy to turn on and off lights. A light switch on a wall, it turns off very easily. If you are electrocuted by AC, it attracts and repels. Certainly not good for you, but there's an opportunity to release. And that's the power that really powers your houses or most of your equipment. Then we look at DC electricity. DC's currently constantly trying to flow from source to load. It has no frequency. So there's no device at the moment that allows you to remotely detect a DC electrical source. You literally have to attach a clamp meter to a DC source to know whether it's live or not. So it can't be easily detected. And every time you switch DC, it tries to arc. It's trying to flow from source to load. So you might have seen the old Frankenstein movies, those big blade switches. That's a DC switch. every time you switch DC, it's trying to arc. So DC typically doesn't like being switched. Any connection points, relays are potential points of weakness. If you're electrocuted by a DC electrical source, you lock on. There is no opportunity to break free. And if you look at even just a standard domestic size solar PV system, it will put out about 6.6 kilowatts. So it's putting out a magnitude of power far beyond an outlet on the wall. Everyone knows not to stick a knife or a fork into a power outlet, yet I see people engaging with solar panels on a daily basis, not even understanding the potential for electrocution. Next slide. So here's just a very quick demonstration of the difference between an AC and a DC electrical source. So as you can see here, it's connected up to 220 volts of AC. It's a very basic switch, and it's powering a heating element. So it's activating the switch, disengaging the switch. You'll see it's very clean, very neat. It just switches on and switches off. Now we connect it to a DC electrical source. As you can see, when you try to disengage it, it arcs. And that is the difference of the nature between AC and DC. Every time, it is just constantly trying to flow from source to load. You try to disengage it, it tries to keep flowing. And that is why why I say or emphasize DC doesn't like to be switched. It does not like to be interrupted. And the more connection points you've got with a DC electrical source, the more potential points of weakness. Next slide. So this is from the Australian and New Zealand standards on the physiological effects of DC on the human body. Now, obviously, that this depends on your height, your weight, your sex, how dry you are, how wet you are, but this is usually works within a fairly well-known band. So up to 2 milliamps, you'll get a slight tingling or prickling if you touch it. It certainly won't cause any harm. Up to 200 milliamps, you'll start to get involuntary muscle contraction, but once again, you won't be badly hurt or badly burnt. But between 200 milliamps and 500 milliamps, you start to get strong involuntary muscle reactions. That's the lock-on effect. You'll start to get fibrillation of the heart. You won't get any deep cell burning damage, but you'll certainly not be very comfortable. But then anything above 500 milliamps, which is only half an amp, we're talking cardiac arrest, lock-on, deep cell damage, and that's the end. You're gone. So it only takes half an amp or 500 milliamps to potentially be fatal. And as I said, even a domestic solar PV system can be putting out up to 9 or 10 amps, and commercial industrial systems much higher. Next slide. So now we'll talk a little bit more about solar itself. You might have heard solar panels or solar systems referred to as solar PV systems or PV modules. PV means photovoltaic, light, electricity. Each cell in a solar panel produces 0.6 of a volt. It doesn't matter whether it's a small cell or a large cell, all solar cells put out 0.6 of a volt. The size of the cell determines the amperage. So small cell, low amps, big cell, large amps. Now those cells are wired together in series to create a solar panel, and then those solar panels are connected in series to create a string. Solar panels can range in size from a little garden light of 1 watt up to some of the modern panels now are over 600 watts per panel. Now, for a domestic solar system, you can have up to 600 volts in a single string by law. And for a commercial, industrial, or utility scale solar system, it can be up to 1500 volts in a string. Now, if you want more output than that, we'll use a commercial string, 1500 volts in series. If you want more power than that, you'll have a second, third, fourth, multiple strings that are then wired together in parallel to increase the output of the total system. Next slide. So there's three types of solar PV systems. The most common is a grid interactive system. So this is the type of system you'll see on every house, on most commercial sites, buildings, factories, etc., etc. And as the term says, it's interactive with the grid. The solar PV system is connected to the electrical grid. So that allows any excess power produced can be pumped back into the electrical grid. That's how, if you've got a domestic system and you're getting feed-in tariffs or credits, that's by feeding your excess power back into the electrical grid. Then the second type of system is an off-grid system, and much the same as it says, this is a solar PV system that is completely independent. It is not connected to the electrical grid in any way, shape, or form. And in order to have an off-grid system, you need solar panels producing power, but to store the power, you need the batteries. So off-grid systems are all connected up to a battery energy storage system. And then the third type of system, the most recent innovation, is hybrid, which is exactly that. It's a combination of a grid interactive system and an off-grid system. So it's connected to the grid, but it also has a battery energy storage system connected to it. So moving on, why do PV systems fail? Physical damage. It can be a branch or an object falling onto the panels and cracking and damaging the panels. It might be an installer who's walked on the panels and caused damage. There's vermin damage, so that's rats, squirrels and the like chewing at the wiring. Weather events such as lightning strikes, hail, water ingression. But by far the most common reasons for solar PV system failure is either using poor quality equipment or a poor quality installation. And note that regardless, even if a solar PV system or a solar panel is damaged, it will still be producing some form of power as long as it's exposed to light. Next slide.
This demonstration, the initial.
So this is just showing you, this is from the University of New South Wales. This is showing you how solar panels burn. It's something that's not very well understood. So what you're seeing here in the top right-hand picture, you're seeing a top view of the panel, and the main view you're seeing is a shot from underneath the panel. A knife has been driven through the panel to create the electrical arc. And as you can see, once the solar panel is damaged, it creates a very hot welding arc. And you'll notice there's not much smoke. There's not a lot of flame. It will just continue chewing through that panel, burning at 2000 degrees Celsius, which is around 3,600 degrees Fahrenheit. And what happens is the glass in the solar panels will melt at those temperatures. You can't see it too well from here, but you'll, if this was running a little smoother, you'd see that that molten glass is dripping down. Now, if the roof material underneath the solar panel is flammable, that molten glass will set fire to the roofing material, and then you have a more traditional Class A fire that evolves very rapidly due to the fire spread change in behavior caused by that air gap between the solar panel and the roof. So here's some examples of what goes wrong in the real world with solar. I mentioned earlier, solar doesn't like being switched. And here you can see the result of burning isolation switches at domestic systems. That's quite common. Next slide. Water ingression and flooding. You'll imagine if you've got solar panels connected down to an inverter, which converts the DC electricity into AC electricity to power the house. If that gets submerged and water and conductivity with electricity, that can create a very hazardous scenario. Next slide. Big one here for us in Australia and also through your tornado belt, hail damage, which shatters the panels. That creates a hotspot in the solar panel. That hotspot can develop into an electrical arc, and then that electrical arc can evolve into a fire incident. Next slide. Here's a couple of interesting examples. So as I was saying earlier, for every incident caused by a solar PV system, you'll probably see another 10 incidents where the solar isn't the ignition point, but it becomes involved in a broader fire. On the left there, you'll see a result of that's a residential incident where the panels didn't cause the problem, but as you can see, the wiring from those panels is damaged, and as long as those panels are receiving light, those electrical wires and cables will be live. On the right, that was an interesting one. That was following a hailstorm at a warehouse incident here in Australia. As you can see, if you look closely, it's about a 900 panel system, very severe hail damage. The owner did all the right things. They activated their disconnection switches to shut down the array. But 3 days later, after the hail incident, those shattered panels receiving sunlight started arcing and started a secondary fire. First responders turn up, can only treat that defensively. They won't risk their lives to save the structure. And it was just extremely lucky that fire didn't manage to penetrate that metal roof, or they would have lost the entire facility. Next slide. So some more recent incidents. It's not just happening at low quality installations. There's some fairly big brands that have had significant problems. You see on the left, that was an incident a few years ago in Long Island. Apple, they had a fairly high-profile fire at their data center in Arizona. Next slide. IKEA have had issues. That was a fire at the IKEA in Philadelphia. Walmart have fairly famously had several incidents. I think they had installations put on, I think it was 263 Walmarts across the US, and within 12 months they'd had 7 rooftop fires attributed to the solar PV installation, which I believe settled out of court. Next slide. So the DC danger zone. What is the DC danger zone? It is the solar panels and the wiring leading from those solar panels to the first point of isolation. There's the potential for electric shock, potential for fire, and of course, if first responders are on roofs, there's all the risks associated from working at height. There is no safe or reliable means of isolating the solar panel at the source, at the panel itself. And up until recently, the standard operating procedure was to try and potentially put a tarp or a covering on the solar panels, which now you'll understand a little better is a really, really bad idea, or simply don't engage, treat it defensively, which obviously leads to much higher property damage and environmental pollution. Next slide. So, of course, there are technologies that try to combat these problems. I've talked a bit about isolation switches, and in a lot of cases, that's one of the main points of weakness because DC doesn't like being interrupted. Most inverter systems in a PV system now have fairly good quality anti-arcing equipment. And then, of course, in the US, you've got rapid shutdown type installations, whether that be microinverters or DC optimizers, etc., etc. I think in the US, you've had rapid shutdown legislation in place for around 10 years now. I think it's the US and Philippines are the only countries in the world that have legislated rapid shutdown. However, these are all electromechanical solutions, and they don't stop the light, they don't shut down the power at the source. They all operate downstream of the solar panels themselves. Next slide. So how do you turn off solar panels at the source? You block the light. Light is the source of power. I've heard some people saying you can't switch off the sun, and that is very true. You can't switch off the sun, but you can block the light and stop the power at the source. Next slide. And that's why we invented PVStop. So PVStop, it's a state-of-the-art polymer film technology. So essentially, it's a black coating that you apply onto solar panels to block the light and stop the power at the source of power production. Our standard delivery system is a 2.5 gallon fire extinguisher type vessel that can be applied from up to 30 feet away, depending on weather conditions. And you literally just aim, squeeze, and spray. And by coating that panel, it immediately blocks the light and stops the power at the source. But because it's used in life risk environments, it has to have other properties to make it safe. So in its wet state, it's fire retardant. It will actually extinguish a Class A fire. In its dry state, it is non-flammable and heat resistant. It's anti-arcing, it's non-conductive. And from a PV system owner perspective, post-application, if the solar panels weren't the root cause of the ignition, it can be peeled off without damaging the system, and that discarded film can be disposed of in just general waste. So it's also, I should say, totally non-carcinogenic and safe for humans and the environment.
Here you'll see the procedure for covering the panels with PVStop.
It's just a quick demonstration.
Solar system panel array safe. Note the number of light globes connected to the demonstration unit, allowing you to see that the system is under an electrical load. This dashboard will measure in real time the reduction of power as PVStop is applied.
So volts times amps equals watts. Watts is the
center of a panel array.
unit of measure to watch.
The panels are only partially covered. The output is reduced to safe levels in a matter of seconds, and the light globes switch off.
So first step is to get a 40% coverage across the center of the array. That is enough to completely de-energize the system,
giving you additional peace of mind that the system is totally safe. With an air temperature of 25 degrees Celsius or 77 degrees Fahrenheit, PVStop is touch dry within minutes and creates a waterproof coating. Once completely dry, peel it off, or it can sit on your panels for up to 12 months or until you're ready to reactivate your system again.
So it's just a very simple solution to an otherwise complicated problem. I mentioned there that 40% coverage is enough to completely de-energize the system. So earlier I was saying volts times amps equals watts, which is power output. That 40% band across the middle of the system, it breaks the circuit. So it reduces the amps to zero. You'll still have some residual voltage in the cells exposed to light, but even 100 volts times 0 amps equals 0 power output. So 40% will make you safe, but we always say best practice is full coverage to remove all or most voltage and all the amps from the PV system. So as I said before, our standard delivery system is a 2.5 gallon fire extinguisher type vessel. Later this year, we'll also be releasing a new delivery system, which is a drone delivery system. So feedback from the market for high-rise, dangerous to access, or really large-scale PV systems, the drone offers a more efficient solution. The drone can carry up to 13 gallons in one flight. It's a monster, and it can cover, I think, what's that work out to be? About 2,000, a bit over 2,000 square feet in a single flight, and can be quickly reloaded. Next slide. So data and statistics, there have been firefighter injuries directly related to solar PV systems recorded in Switzerland, the UK, and the US. There would be more, but good evidence-based data is still reasonably challenging to get a hold of. The best research I've seen on this is out of BRE Global in the UK, where over 58 logged incidents, there were 9 injuries. This is fairly old data. That report was released in 2017. There's been a hell of a lot of growth in solar around the world since then. There was an incident in San Francisco back in 2015 where 2 firefighters were electrocuted through an unbroken stream of water from a branch. When they were on the roof, they were standing in a puddle of water. They got electrocuted. Fortunately, not badly injured. But I'm also quite often asked, has anyone actually died directly attributed to solar panels? And unfortunately, the first incident where it was proven that the solar PV system was the cause of a death was actually in Dubai in 2018. It wasn't a first responder. It was just someone from the general public. The irony, it was a 2-panel system on a caravan. They touched the wrong wires, cardiac arrest, and that was it. So I'm quite often asked, how many solar panels are dangerous? In the wrong set of circumstances, as little as 2 panels can be fatal. Next slide. So one question I'm quite often asked with our solution PVStop, when do you use it? When can it be deployed? And it can be used either preemptively during a fire or operational incident. And it's also very effective for post-incident application. But one thing I also want to express is from a firefighter or first responder perspective in the countries where we have rolled out, it's been very effective. It improves safety for members, but we often see once fire departments have adopted it, we start to get the pushback. And why are firefighters bearing the brunt or the onus of safety responsibility? Why? When responding to residential, I think residential type systems are always going to be the responsibility of first responders. I don't think you're going to see residential installations take responsibility for being able to shut down their systems. But when you're talking the larger commercial, industrial, and utility system owners, there should be some onus on those owners to mitigate these risks. So they should have a supply of PVStop or a similar de-energizing solution on site, ready for trained first responders to utilize if there is a fire incident, and be working with the local fire departments in the community safety programs. Solar should just be another tick on the box on the risk assessment. You know, do the hydrants work? Do the fire doors work? Do you have a PV system on the roof? If so, provide the department with an electrical schematic. Where are the entry points to the roofs, the access points? Where are the inverters located? Where's PVStop located, etc., etc. So next slide. So preemptive response. This was a incident in the Netherlands where it was the residential array. The inverter of the PV system was smoking. The resident called the fire department. They weren't trained, didn't have the knowledge in how to isolate the inverter. So they used PVStop, applied PVStop to the panels on the roof, stopped the power at the source, and of course the inverter immediately stopped smoking because it was no longer receiving power. So it worked very effectively before an electrical incident evolved into a fire incident. Next slide. This is one of the first operational incidents where PVStop was used over in the UK at a London school. Once again, the PV system was not the cause. It was a fire in the toilet block downstairs. The fire got up into the roof cavity, damaging the wiring, making it dangerous for first responders to try and access the fire inside the roof cavity. They applied PVStop to de-energize the entire system. They could then get into the roof, use water to extinguish the fire, and saved a multi-million-dollar building. 12 months earlier, they hadn't had the capability. They lost the building. Next slide. This was another incident, once again in the UK. Once again, the PV system was not the ignition point, but it became involved and became dangerous. They applied PVStop, de-energized the system, and then once again could save the structure. Next slide. This was an interesting one out of Australia. So it was a warehouse fire, a big solar PV system on the roof. Once again, PV system was not the source of the fire, but the warehouse was destroyed and needed to be demolished. The problem was it's dangerous to demolish a building at night time, and it is very dangerous to try and demolish a building with a live PV electrical system on the roof. So they used the contractor used a scissor lift, sprayed PVStop across all the array to de-energize it, and then that structure could be safely demolished. So that's a good example of a post-incident application of the product. Next slide. So, as Gary alluded to before, the first responders are aware there's risks, but quite often they're not aware of the depth and breadth of the risks. So this is where training and education are so critical, not just for firefighters or first responders, but all stakeholders, including PV system owners and operators. Data has been very scarce up until now. There hasn't been a coordinated national reporting system in the US, which it's fantastic to see that the US Fire Administration have got a huge initiative going on right now, the National Energy Response Information System, NERIS, which should be rolled out shortly, and that will give consolidated, far more accurate and better evidence-based reporting for all first responders across all aspects of fire protection, but it's very encouraging to see that solar and battery energy storage systems will be incorporated into this system. So that's going to be a massive step forward, and you will see a lot more data, and you'll start to see these problems are much more significant and wider ranging than anyone is aware of at this point. So once again, going back to the commercial, industrial, and utility scale PV system owners and operators, they have an occupational safety and health obligation. They should be installing risk mitigation systems for these rooftop risks that they're installing. And by investing in early detection and corrective equipment and collaborating with fire departments, this will really close the current safety gaps. Next slide. And so that's it for my part of the show. If Dan's with us, I'll be handing over to Dan Murray from the New York Fire Department, HazMat, to talk a little about FDMY's operational experience and how they're training in the use of risk mitigation equipment.
Good morning. Do you hear me?
Yes, gotcha.
Oh, okay. I don't know if you can see me or not, but yeah, I had a little trouble logging into the web to this website here. But good to see you, Jim. I know Gary's on too, and we've been working together for several years now to deal with emerging problems that come along with emerging technology, and of course, solar is one of those. The solar panels we found in New York City, where we have been pretty quick to adopt, the green energy. Solar panels are popping up all over the place, and we were looking for solutions to potential problems. We adopted the PVStop product. We currently carry it on 13 of our HazMat technician and specialist units, and we've had success with the product. Currently, we used it recently. We had a fire in Staten Island.
Next slide, by the way, we can pull this up, I think.
Okay, great.
Let's see. There we go.
All right, so I think what we're looking at here is we have these car charging, solar-powered car charging stations all over the city. And we've had, I believe so far, 3 of them have gone on fire. One of them, the solar panels, when we arrived, were actually completely engulfed in flames, so PVStop was not required. One of the earlier ones, though, we did use the PVStop to ensure the safety of our members so they could operate and extinguish the fire and overhaul the area. Yeah, so I think that, and then we also used it. There was another fire in Staten Island where we applied the product to the panels to safe the area for our members. So yeah, it's been working very good for us.
Yeah, and the next slide, we can, if you like, Dan, that we can roll to the next slide and show the FDMY training video.
New York City is leading the way towards a future producing a healthier and more sustainable environment that's less reliant on fossil fuels. Renewable energy comes from several different sources, but in this video, we'll focus on photovoltaic, also known as solar panels. Solar panels are being installed all over New York City, including roadways and parks, and on both residential and commercial buildings. Now, firefighters face a very real threat from arcing and electrocution when operating around solar panels and electric conduits connected to the solar panels. So, even when the FDNY shuts the electrical utilities off at the main panel at an emergency, solar panel systems will continue to produce power. PVStop is an instant liquid tarp which can be sprayed onto solar panels from a safe distance. PVStop effectively turns solar panels off, even when they're exposed to sunlight. PVStop allows firefighters to cover solar panels in a matter of seconds, as seen in this video with our light bulb display. The solar panels do not need to be entirely covered for electrical output to be reduced to safe levels. PVStop is designed to be used before, during, and after an incident to make solar panel systems safe. For example, if a solar panel inverter is overheating or faulty wiring or components are arcing, applying PVStop to the solar panels will turn off the solar panel system immediately, mitigating both fire and electrical risk. Its non-conductive spray dries into a rubber-like film which covers the panels and stops the production of electricity. Applying PVStop during a fire incident at a building featuring a solar panel system will immediately mitigate the solar panel electrical risk and allow crews to safely engage in offensive firefighting tactics. Although solar panel systems produce little or no electricity at night, PVStop should also be used during or following nighttime incidents. This will ensure that the solar panels remain deactivated when the sun comes up to avoid the risk of secondary fire incident if the solar panels are damaged or faulty. Now here's a video showing a light tower that is solar powered. Applying PVStop may require the use of a tower ladder or an access area that's above the panels for safe application of the product. Here, Con Ed attached an amperage meter to the tower to demonstrate the immediate impact of PVStop in de-energizing the solar panel system. First, firefighters need to identify the orientation of a single solar panel, which is a rectangle with a short side and a long side. Next, spray a line across the center of the short side of the panel. This is enough to dramatically reduce the electrical production of the entire solar panel. Lastly, once a centerline spray has been applied to all the panels, FDNY members will then apply PVStop to any remaining uncovered areas, reducing DC electrical output to zero. This video is a classic example of less is more. A quick covering across the center line is sufficient to reduce electrical production to safe levels. Now, until solar panels are covered with PVStop, there are safety concerns when operating in the vicinity of solar panels. When an incident commander is notified of the presence of solar panels, consider the use of PVStop. All squad companies, HazMat Tech Engines, and HazMat Company number 1 carry this product. And as per AUC 351, a safety officer should be assigned to the roof to oversee operations when firefighters are working in close proximity to a PV system. Note that the firefighter maintains a safe distance on the perimeter of the solar panel system and avoids walking over the electrical conduit in between individual panels. Now, applying PVStop in rain conditions presents additional considerations. FDNY testing has shown we tend to over-apply the PVStop coating. The thicker the coating, the more time it takes to dry. This is not an issue unless it's raining. In heavy rain, our tests have shown the product can run off in a matter of minutes, possibly causing the panels to regain the ability to produce energy. So it's recommended to committed member to constantly surveil the solar panel system in rainy conditions to see if an additional application of coating is necessary. PVStop is environmentally friendly, does not damage the solar panel system, and contains no PFAS, PFOS, or PFOA chemicals. The rubbery coating can be peeled off after drying and disposed of as general waste. As seen in this video, PVStop can be used in many scenarios to combat solar panel energy production and keep our members safe.
There we go. Couldn't have said it better myself.
Yeah, so that we did that what the main solar array where we did it was actually on the roof of one of the firehouses, and you can see we used one of our drones to help with the filming, and it works. You know, we set up with the light bulbs, and you know, you can see it's really, like you said, the only way to stop the generation of DC power is to stop the sun, right?
Yep, block that light.
Block the light.
Right. Well, thanks for that, Dan. And I think that's the conclusion of the main presentation. And I think we've still got a few minutes left to hand over for any questions from the audience.
Yep. And I think we got Tyler and Stephen monitoring the chat. So if there's any questions in there, if you guys want to throw those out there, and then we can, we'll give Jim all the tough ones. And then if needed, you know, Dan and I will take the easy ones.
Alrighty. The first question we got is, what is the shelf life for PVStop?
Good question. So the product warranty is 3 years, but the shelf life is 5 years. So as long as the hydrostatic test cycle of the cylinder. So it's important to know the cylinders with PVStop are not refillable. They are a one-use only item, because when you do discharge it, it does dry into that kind of latex-like film, which makes refilling the cylinders problematic. So they're literally a one-use only item. So yeah, three-year product warranty, 5-year shelf life.
How does freezing temps affect the product as far as drying?
Yeah, that's a great question. We've tested the product up in Finland, up in, I think it was about minus 15 degrees Celsius. I'm not sure what that is in Fahrenheit, but it's bloody cold. When you apply PVStop in freezing conditions, it doesn't dry on, it freezes on. So it's still effective because you spray it on, it freezes on, it's still blocking the light. However, it does impact the ability to peel it off. You won't be able to peel it off, it's frozen on. So to remove PVStop in sub-freezing conditions, you would need a high pressure water blaster, or scrape it off, or wait for warmer conditions to prevail. It is very important though, do not let those cylinders freeze. It is a water-based polymer, so if you store the cylinders in sub-freezing conditions and the product freezes, it voids the warranty, because once it thaws out after being frozen, it goes gluggy. It does lose some of its performance. But as long as the cylinder itself is not frozen, you can apply it in sub-freezing, no problem. It will still mitigate the electrical risk.
How many square feet does the 2.5 gallon extinguisher of PVStop cover?
I was prepared for this one. I'm a metric fellow, so in metric terms, it'll cover about 45 square meters, which converts to around 500 square feet for a 2.5 gallon.
How much of PVStop?
So glad I wrote that one down.
How much should a department own a PVStop?
Look, that depends on the size of the department, obviously, and the, I suppose, the risk profile of the department. I would never envisage that you would have more than one cylinder on every pump or first response vehicle, but as said, that's up to the individual department, as Dan alluded to before. If in the FDMY, it's a HazMat capability. So it comes down to geographic coverage, the risk profile of the department, but we are very happy to work in with the departments and recommend how they should best adopt it based on their own individual standard operating procedures.
What is the price point?
That look, that's probably more of a Safeware question than a question for me. I know for the list price I think is around $700, but I think with discounting structures, etc., and for first responders, I believe the goal is to bring it in under 500 US, but that's just an approximation. Once again, what you'd have to check with your local rep.
If they get a hold of their Safeware rep, we can definitely get them some quotes, including the shipping, right? Because it's a pressurized cylinder, so we got to take that into account. But a lot of it, if you contact your Safeware rep, a lot of this, the PVStop is on a lot of the bulk purchasing contracts, including Omnia that Safeware has. So you'll be taking advantage of economies of scale, right? All of this Safeware is providing this product across the whole US. And obviously everything is like the Costco model, right? The more you buy, the cheaper it is. Safeware is sharing that economy of scale with everybody in the country. So rather than you trying to reach out and find somewhere where you can buy one, Safeware is buying large quantities so that they can give the best pricing out to even fire departments that are interested in one extinguisher are still going to take advantage of that economy. So certainly we will send out some information, everybody that registered, or just if you're already in contact with your Safeware rep, reach out to them and we can get you that info.
Yeah, one is the FDNY video available on YouTube for other departments to use?
I don't know that. I don't know about that. I'll have to find out, and if there's a way we can get that information out to you.
Hey, Chief, I think I saw it in the Dropbox that FDNY or the Google Drive that FDNY shared after the battery symposium. So we do have that. If anybody doesn't have that link, get a hold of your Safeware rep or training@safewareinc.com, and we can reshare that send it from your government email address. FDNY has been phenomenal about sharing everything that capabilities they've built for both lithium-ion batteries and now their strategy and tactics for solar. So we can share that publicly available drive with you where they're been sharing all of their knowledge in. I think we got time for one more, Tyler.
That looks like all the questions that I have.
Great. If you're watching this, some people probably may see this recording, may not see it live. If you come up with a question, certainly you can email us training@safewareinc.com, and we can get that back to questions related to FDNY. I can forward those on to Chief Murray. Product questions we can get over to Jim and his team. They have a team here in the U.S. as well. And then also, if you have training questions, we can help with that. And then if you have pricing or procurement questions, we'll get you in contact with your local Safeware rep who can help you with that. So Jim and Chief Murray, thanks so much for taking the time out to put this together. I'd say it's a burning issue, pun intended. Something that we're definitely going to see more and more of. So thanks again.